Welcome to the Power Rule. This is video number 2 in the Derivative Rules series of videos that I have for you that are going to enable you to knock out derivatives. Don't forget to subscribe and like. Let's dive right into the Power Rule. All right, first off, let's remember our different ways of identifying derivatives. So first, we have this little accent mark that we call prime. So we have f prime of x, or we could use y instead of f of x and call it y prime. But it's a weird notation, but using that little accent mark to denote a derivative. We also have this slightly newer way of using what's called d over dx. This d over dx is basically the d is for derivative. It's the derivative with respect to x, meaning that like the function that you're using has an independent variable of x. And then in the brackets is the actual function that we're trying to find the derivative of. And then you equal, well, the derivative, right? So you're saying the derivative of this function with respect to x is right here. So it's just a slightly new notation that you may like, and you're going to see a lot. All right, here is the power rule. By far, probably one of the most used rules in all of derivatives. Very simple rule. Here's how it works. If n is a rational number is any number that can be written as a fraction. So if n is a rational number, and your function is x raised to the n, then here is how you find the derivative. So you take your function, x raised to the n, that's your standard function. Now the derivative is this. The n falls down in front, right there, and it multiplies by the x, and then your new exponent is n minus 1. That's it. It's that easy. So your exponent falls down in front as your new coefficient, and your new power on the x is 1 less than the previous one. It's that easy. That is the power rule. Please study it. Please understand it and remember it. It's really easy to memorize. Here it is, the same rule, just using our new notation. The derivative of this function, x raised to the n, with respect to x is, again, let me just go through it one more time. So the n, the power, falls down in front as your new coefficient. Your new power is whatever your old power was minus 1. That's it. That's how easy the power rule is. It's really, really simple. Now, why is it called the power rule? Because it applies to all power functions. Any power function can use the power rule. So a power function is a function that can be written in the form f of x equals x to the n. Again, that's a power function. The only restriction is that n has to be a rational number. Now, rational numbers, don't forget, they include both positives and negatives, whole numbers, and even fractions, right? Just can't be irrational. But as long as you're rational, that's a power function, and you could use the power rules. All right, let's dive right into it and show how easy it is to use these really super simple power rules. So here we have the power function f of x equals x. Now you may be like, well, where's the power? Oh, come on, you guys all know there's a little 1 right there. All right, so to find the derivative of this function, here we go. Ready? The power of 1 falls down in front. My new power is the old power 1 minus 1. That equals 1 times x to the 0. But I hope everybody knows that x raised to the 0 is equal to, you better be yelling it out right now, 1. So we get 1 times 1, which is 1. So the derivative of f of x equals x is 1. The derivative, with respect to x, of x to the first is just 1. There it is. That's the power rule in action. Let's do another one. F of x equals x cubed. The derivative of this function is, here it goes, ready? 3 falls down in front as my new coefficient. X to the 3 minus 1, that equals 3 times x squared. Done. The derivative with respect to x of x cubed is 3x squared. It's that simple. And you can even start doing most of the work in your head probably. Oh, but wait a minute. What's going on with this problem? Don't forget, roots. Any root function can be written as a power function. So this can be written as x to the 1/2. You guys should all know that. All right, so now that I wrote it as a power function, I could go ahead and find the derivative. Here we go. The power of 1/2 falls down in front as my new coefficient. My new power is 1 less than my old power. That's 1/2 times x to the negative 1/2. Now, that's actually a pretty good answer, but in the world of math, It's kind of like using bad grammar. We don't like using negative exponents in a final answer. Again, it'd be like using the word ain't in an official English paper. We just don't want to do it. So remember, negative exponents do not make you negative. They just simply move you to the denominator. So I have 1 over 2, but now joining that 2 in the denominator is going to be x to the positive 1/2. And then I could even do one more item there. I could change that x to the 1/2 back to a square root, but it's in the denominator because of that negative exponent. So the derivative with respect to x of the square root of x is 1 over 2 square root of x. How easy was that to apply the power rule? All right, let's try another one here. This time we're going to use a cube root. Once again, all roots can be written as power functions. That's x to the 1/3. So the derivative of g of x, g prime of x, is going to be 1/3 falls down in front. My new power is 1/3 minus 1. So I have 1/3 times x. Let's see, 1/3 minus 3/3 is negative 2/3. Don't like a negative exponent, so I'm going to have that x go down to the denominator to join the 3 with x to the positive 2/3. There is a beautiful, wonderful final answer. And then using that new notation, the derivative with respect to x of the cube root of x is 1 over 3 x to the 2/3. Hopefully you're picking up on how easy this rule is. All right, that's the same problem I just did. Sorry, I didn't mean to repeat it. All right, here's another one. Now, you might be like, what? Wait a minute, that's a rational function. But hold on a minute. We could actually write this as a power function because I could move the x to the 5th back to the top with the negative exponent. So I'm literally doing what I was talking about earlier with negative exponents in reverse. If you have a positive exponent, but you're in the denominator, you can move to the top with the negative exponent. Now, you might be like, well, I thought you didn't want negative exponents. I don't, but because I could write this with a negative exponent, it allows me to write it as a power function. Now I can find the derivative by simply applying the power rule, because it's got to be a power function to use the power rule. Got it? So the negative 5 falls down in front as my new coefficient. My new power is negative 5 minus 1. Now, I want to make a note here. Notice I always show my work. That's not a requirement. If you can do that work in your head, by all means, just jump and say, hey, wait a minute. I know negative 5 minus 1 is negative 6. Now, here's where I don't want to leave a negative exponent in my final answer. So I'm going to leave the negative 5 on top because it's nothing wrong with the negative 5. The negative 5 actually has a positive 1 exponent, so don't move that negative 5. It's the x that's going to move to the bottom where it can have a positive exponent of 6. So the derivative with respect to x of 1 over x to the 5th is negative 5 over x to the 6th. Easy, 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 easy. All right, here's another one. Okay, this is what I call double whammy. It's a fraction and it's a square root. All right, let's take this in stride. First, all roots can be written as power functions. That's going to be x raised to the 3/4. Powers go in your numerator, roots go in your denominator. So the root of 4 is in my denominator, the power of 3 is in my numerator. But I don't like it being in the denominator. It's not officially a power function yet. But I could write that as x to the negative 3/4, and now I have officially changed this to a power function. Now listen, that has nothing to do with the derivative, but I'm just turning my original function into a power function. That way I could use the power rule. So the derivative, g prime of x, is going to be this. The negative 3/4 falls down in front. X raised to the old power of negative 3/4 minus 1. That's going to be negative 3/4 times x. Let's see, negative 3/4 minus 4/4 is negative 7/4. Don't like negative exponents, so the negative 3 is fine on top. The 4 is fine on the bottom. That's coming from right here. But joining the 4 in the denominator is going to be x, but now to the 7/4. That way, I have a nice positive exponent. So the derivative with respect to x of the function 1 over the 4th root of x cubed is negative 3 over 4x to the 7/4. That's it. That's how easy the power rule is. All you have to do is make sure that your function can be written as a power function. And if you're like, it can't, like all these problems could be written as a power function. If you figure out, for whatever reason, you're really good at algebra and you're like, listen, I've tried everything, I cannot turn this into a power function. Well, then I'm sorry. We're going to have to use another rule that we're going to hopefully learn later on here. But if you could write it as a power function, you could use the power rule. This is one of the easiest and simplest rules to use. All you have to do is drop down your power as your new coefficient. Your new power becomes n minus 1. It's that easy of a rule to use. Hopefully you love it as much as I do.